just going to look in the index really quickly. The other one I want to, okay. They have RMS on page 196. Just a quick look. RMS. They're just talking about the definition of RMS and signal noise ratio. Yeah, and again, those are kind of like standard in the literature, so they need to use those. And if they have to have them, why not just recycle them if they're not worried about computation? And a lot of times they're not, because they're just worried about the end result. So I don't find anything in this book and the other computer music book. I'm just going to assume nobody cares. And I'm going to write a post saying everybody should do absolute average and drop RMS. So absolute average, absolute category rating, no, an E, yeah, so RMS had one more discussion at page 339. Page 339. Mixing or summation of channels. Yeah, this talks about the RMS being increased by uncorrelated signals by 3. If they're the same, then they'll increase by 6, which is double. Yeah. And actually the same is true for the average of the absolutes. Average of the sum of the absolutes. And you don't have to square root anything, like I've just said a few times. So there's one more book I want to look at. And this is the computer music book. This is a great book. Elements of Computer Music. There's a lot of C code in here. They show you how to do a FFT, a DFT, and a FFT. This is probably the FFT code. Looks like it. No, this is a subtractive synthesis model. So I'm going to look up in the back. RMS. Used in page 34. Yeah, for those of you who don't know about computer music, and it's probably most people, computer music is like a weird, it's interesting. It's like the academic continuation of classical music into the, like started around the, well, you get into a fight if you talk about when it started, but like very early 20th century classical, contemporary classical composers, whatever that means, like Varese, and going into the 50s, like even like these really famous avant-garde guys like Berio, Ligeti, Stockhausen. They were interested in new mediums. They want to make new sounds, so they started looking into electronic sources, and that led to, of course, when the computers started becoming popular, people doing this. And like some of the guys I studied with, like Charles Dodge, would use a computer to process and synthesize sound. And there's a lot of stuff happened in France and Germany to that effect in the 50s and 60s. And now we have like texts that are like pretty serious sound synthesis books for like a very small niche of composers. And well, nowadays I think it's going back the other way, and they're getting less technical because we've got more tools now, and some of them have GUI interfaces, and that means you don't have to write code. And I don't know if that's a good or a bad thing, but I hope that the technical side can be supported by the computer music composers nowadays. Well, we'll see. Hopefully both sides can continue in parallel. The people who don't want to program, the people who want to program, and they won't hate each other, because they shouldn't. They should get along. They can make great things together. That's the idea anyway. And now I'm looking at the page about RMS. So yes, isn't this nice? See this? If you don't remember from 3rd or 5th, 6th, 7th grade, the bar around the number is the absolute sign. It's actually been a while since I saw that. And that top one is just an absolute value being averaged, the sum of the absolute value being averaged. And this one here is the very complicated, much more complicated root mean squared. Take the values, square them, and the power to 1/2 is the square. So let's see what he has to say. We might obtain the average difference between the amplitude of a sinusoid and 0 by adding up all the absolute values of amplitude and taking their arithmetic mean. Yes, that's what I have been talking about. So obviously I'm not a genius and I don't invent things, but sometimes I think I reinvent the wheel for very simple things, and this is one of them. Using this method for the case of 4 equally spaced measurements would yield an average difference of, and he shows one of those examples. A far more common approach to measuring the average value of the waveform is to use the so-called root mean squared. As implied by the name, we square each, and he shows how to compute it. Similar, okay, so where's the discussion about it? Yeah, so, I mean, one thing to note immediately is the values for root mean squared and absolute values squared are very different. So, here. One reason, this is in the footnote, one reason for the widespread use of the RMS method of measuring the average signal amplitude is that the RMS value expresses the precise level of a steady, non-varying signal of equivalent power. Let's think about that. Okay, I don't understand that yet. Let's think about that. Thus, 120 VAC household current can deliver the same amount of power as 120 VDC because 120 is actually the RMS value of the voltage in a wall socket. The peak value of the household voltage is actually 120 divided by 0.707, which is the average, the RMS of a sinusoid. Yeah. 120 divided by 0.707, which is 170 volts. That's, I don't know what that really means. So that's talking about power. Ah, that's interesting. So when they say 120 VAC, they're talking about the RMS value. So that means the actual peak-to-peak value is 170, not 120. That's like a weird fact. So 170 volt peak-to-peak AC is the same as 120 volts DC. And I don't see how that helps me in this, explain this. Okay. Okay, maybe I see. Yeah. Yeah, so by steady, non-varying signal, he means a sinusoid. Actually, any signal with equal, with no DC leak that repeats itself will have this property pretty much. Is that true? No, that's not true. For example, if I have a square wave, then there will be more power. The power will be 1. Instead of, the RMS value will be 1 instead of 0.707. Yeah, I'm not sure. I really don't know what that means. And I mean, I really don't understand that explanation. I could email Richard Moore. That's one thing that I've been doing lately, just emailing authors. People usually are very happy when you give them, you just tell them what you're doing and what you're interested in and what your question is. Yeah, but anyway, I'm just going to go ahead and now I realize there's not much of a reason for using root mean squared. One thing is you can plug it into all these other formulas that exist, but we're not doing anything like that. And if we need to, we can change pretty easily. So let's see. Yeah, so we compute total as just the average, the absolute values. Then we stick it into, so we take the average plus, this is interesting. We take the last, yeah, we take the last, minrec dB. Okay. So noise floor height is probably being computed somewhere else. Let's look for that. Previous. Okay, so that just gets initialized to 20. So that's an